The changing ecological and social environment of modern society has seen a call for new scientific understanding of the Earth. A significant part of this understanding involves the collection of past evidence of climate changes, which often exists in the form of paleoenvironmental proxies. One example of a naturally occurring proxy involves the annually resolved coral records of changes to ocean temperature, rainfall, and water clarity. Coral core proxies analyse the changes in skeletal geochemistry, or growth rate of a coral core, a factor that is influenced greatly by the ocean conditions at the time of growth. This technique allows scientists to date past events of ocean warming and acidification. Coral core analysis uses uranium-thorium dating to chronologically date when certain environmental conditions occurred. Coral cores are collected in a similar process to that of ice cores. The coring method uses a 24-inch coring drill with a 4-inch diameter core barrel. After the core is extracted, the hole is filled with a compatible substratum to avoid damage to the living coral. The cores are then cut into slabs along the growth axes to maintain chronological order of layers. The majority of coral cores are collected from fossilized reef-building corals, known as homotypic sclerotina corals. These corals require very specific environmental conditions to reach optimal annual growth. The rapid growth rate of these corals, at 0.3 to 2 centimeters a year, and annual responsive density banding, allows scientists to reconstruct a chronological understanding of how past environmental conditions may have varied from the optimal narrow climate. Additional to growth bands, scientists use the oxygen isotope ratios to infer information on the ocean temperature. A higher concentration of O18 found in the layer of a coral core indicates that more O16-enriched water was held in the Earth's global ice pack, and thus implies cooler ocean temperatures during the time of growth. The information gained from coral core analysis is an annually resolved proxy and is thus considered a high-resolution source. The dating of these layers allows for a very detailed chronological understanding of the climate experienced in the past, with the ability to date events to exact years. A recent study conducted at Heron Reef on the southern Great Barrier Reef set out to investigate the changes to ocean temperature observed during the Holocene period. The study used uranium-thorium dating of pyrite corals to conclude that the ocean temperatures experienced in the southern Great Barrier Reef in this period were cooler than previously expected. Despite the notable value of this paleoenvironmental proxy, it is limited by current ecological processes. The current trends of ocean acidification has seen surface pH levels decrease by 0.1 pH units, increasing the acidity of ocean water by 30%. The increasing acidification of the oceans poses a threat of damaging the chronology and value of coral cores. The growth patterns of reef-building corals are considered annually resolved. The study of these growth patterns, including density banding, allows scientists to assess whether the optimal climate conditions of a coral were met in a particular year, or if the coral was placed under stress. The use of coral cores as a paleoenvironmental proxy is considered an adequately precise technique for dating past climate changes and events.